Hey, welcome everybody.
So this lab we're going to call Topographic Profiles. It's related to really more Earth's surface and topography and stuff that comes at the tail end of the lecture if you're in my classes, related to the tectonic plates and volcano activity, um, you know,
Shifting away from weather and atmospheric phenomena to um, surface and land related um, material. So in this lab, what I'm going to have you guys do is
take a 2D map of a place, and what we're going to be attempting to do is then take that and plot it onto something that appears to be more not 3D, but at what's called a profile view of that thing. So it's like you're looking at it from a side view or from a side perspective, as if you had tilted this up this way. As if, imagine like you were on the ground level looking out at, this is a mountain, this is actually an island in Hawaii, and as if you were looking out from, the ocean on a boat and you were looking out at the mountain, what would that look like to you? Because you would have a different perspective as opposed to what we see in this picture is more of like an aerial shot from a straight down perspective. So we're basically going to take this and tilt it sideways using this little graph here, and that's going to give us this kind of perspective. Okay? So this is definitely a more hands-on type of lab. Well, let's get started. What we have going on with this map is, like I said, we call this topography, and each one of these little lines are called contours, and these contours are meant to represent the elevation of the elevation and the variations of the topography. So again, land phenomena of this area. So how it works is each one of these lines represents a different elevation in space on the surface. So like for example, at the top here, you see it says 13,000, and then 12,000, 11,000, etc. These are in feet, and the way you look at this is you observe it in a way of, okay, first we have to ask ourselves how far apart in the spacing are the lines from one another, because they will be consistent. In this instance, like for example, if we start back at that 1300 and we count our way down, 1300, or I'm sorry, 13,000, 12,000, 11,000, 10,000. See the trend? Every difference between each line is 1,000 feet. So that means that we can kind of count these through. What we're really trying to plot is every 1,000 feet, how does the mountain kind of slope upwards? And where is it the steepest, and where is it the not so steep kind of area? Okay? So let's get started. Having this information here, what we're going to do is we're going to use our little plot here, okay? And forgive me that these aren't printed perfectly, but we're going to reference A and then A apostrophe. So that distance there is going to be, let's say, the perspective that we're looking for. And as I put here, A and A, that's kind of what we're representing. So the best way to start doing this is to take your graph, and we're going to work our way as if the bottom of the graph is 0, like I said, being on a boat, and then at the top, if you count these out, there's 14 of these, so this would be 14, whether it's 14,000, 1,400, 14, whatever it is. That's related to the map itself. And it doesn't necessarily mean that it's 14 or whatever it is. It just depends on the map. This is not always going to be 0. In this instance, since we know A, this is Hawaii, and B, it goes from 1,000 to here, well, 0 would be the ocean, okay? Not all of these examples are going to be like that. You're going to follow it to how this bar here, how that tells you what it's telling you in the as far as how it's graphed across the topography, across the contours. So I'm going to get started with my graph, And I'm going to fold this in like this. Okay. And then I'm going to place that kind of right above the line I have that's A and A apostrophe on the map, something like this. Okay. And then I'm going to essentially plot out where the contours meet this line. So like, for example, here is where A begins, and here is where A apostrophe essentially ends. Okay, so I'm looking at the line here and what I just marked. And then what I'm going to do, forgetting about not even considering what the values are yet, but then I'm going to make little hash marks like this on the very bottom where the contours meet up with this line here. So truthfully, I should have made this fold a little bit tighter, right up against the bottom of the graph like this. That's a little bit more appropriate, okay? So now I can get this nice and tight on here. All right. And so I have a much better perspective of what I'm working with. So here's where my A is going to be. And then I'm just going to start making little marks along this. Every time one of these lines crosses this A to A apostrophe, I'm going to make a mark on the graph spatially corresponding where it meets the how I'm going to plot it out on the graph. So just like this. Every one of these, imagine as if they're continuing onto my graph, and I'm just going to continue to create little marks like this. Okay, here we go. And notice as we get a little bit further along, the spacing between them starts to widen a bit. When the spacing of contours is wider, that's showing you that the slope is not as steep, okay? When the spacing is closer together, that means that the slope is much steeper. Now, once we have that, the next thing to do is going to be to plot out the numbers here for my, so basically these marks are going to be my x-axis. Now I need to define what the y-axis is. Well, like I said, this very bottom line, I can actually expand this now. This very bottom line is going to be 0. And the reason I know it's going to be 0 is because on the map, as I was saying, this is the final line here, which it has a 0 elevation. So I'm going to put a 0 here. Okay. And then I'm just going to work my way up. We know they're every 1,000. I'm just going to start writing these out. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8, 9, 10, 11, 12, 13, 14, like that, okay? And so at this point, what I'm going to do is I'm going to reference, sorry, as I'm trying to juggle these around, I'm going to reference A, and I know A is at, I'm going to reference where that first little target was, which was here. So I know that that's 0. And then what I'm going to do is I'm going to look at where 1,000, the 1,000 mark hits, which is this one here. So let's see. Yeah, these were, let me double check. These are the right thing. Actually, it's supposed to be, yeah. So this is, let me make a little note for myself. Right there, like that. That's A apostrophe. So A apostrophe here, and then A here, okay? Meaning that this one is going to be 0. So this is going to be my starting point like this. Then we have 1,000. So what I'm going to do is just draw a little imaginary line straight up like this, okay? Then we have 2,000, which I'm going to just put a little dot like this, and a little dot at the 2,000 mark, 3,000, okay, up to 3.
etc. So I'm going to stop the video for now, and I'm going to come back and I'm going to show you how all of this comes together. Okay, so I went ahead and plotted out all my little dots, and I was kind of finding out, by the way, use a pencil, makes a big difference. But I was plotting these out, and I found myself kind of leaning over because I'm right-handed, so I started using, kind of a straight edge from this little business card. So you should use something with more of a straight edge or a ruler to really do this the right way. But once I got all of the little marks to sync up with the plots the marks that I made on the graph, now we're ready to simply connect the dots, okay? And that's pretty straightforward. We just simply draw a little line like this, making sure that you're connecting the dots in the right place. Okay, so the real takeaway from all of this, well, actually, let me get to that 1 second. Now, we do have one place where there are two plots of the same elevation. And if you look at the map, you can recognize that that location is right here where the 1300 is. So that's the very peak. So what ends up happening is you have 1300 and 1300, and in reality, the mountain kind of peaks over a little bit. It probably goes to 13,200 or something. But again, remember, our contours are values of 1,000. So as it makes its peak, it actually comes back downwards in here as it goes up, 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 peak, and then comes back downwards like that. And so that's what we see here. So what we're going to do is when we get to this part up here, we're going to do a little bit of an arc like that, okay? And then we're going to drag it back down like this, and we're going to just continue to connect these dots. Okay, So I was saying do your best to connect the dots the best you can. And the takeaway is that you should be able to recognize that the left side, okay, let's just call it the western slope, is quite a bit steeper, especially at the peak, and then things get a little less steep as you go down the east side of the mountain. The correlation between that is, like I was saying earlier, the closeness of how close the contours are to one another. So like, for example, they are much closer together here, and then they get spread apart further as you go this way. And so that's what we're actually representing when we see the map have a little bit of variation like this. And that's it. You're going to be turning in some screenshots, pictures of your plots, and you're good to go. Thanks.